Okay, we are on lesson 43, Algebra 2. In this lesson, we're going to be talking about a concept called sine, cosine, and tangent. And you've probably heard of these, but have no idea what they are, so we're going to learn about them today. Now, the abbreviations we use are SIN for sine, COS for cosine, and TAN for tangent. So that's the beginning. So let's just start with these right triangles. We have three right triangles here. I know they're all kind of crooked. They all have a 30-degree acute angle. The side opposite of the right angle, this is the right angle, is called the hypotenuse. And so that's something we learned when we learned the Pythagorean theorem. Okay, and these two are called the legs. Now, if you look at these, whenever you have a right triangle with one equal acute angle, then the triangles are similar. Because they're right triangles, so they have these angles are all the same. If these are the same, then because there are theorems that we learned earlier, then these must be the same. So these are similar triangles. So we can say that they're proportions. So if we want to write a ratio for the opposite of 30-degree angle to the hypotenuse, this would be 2 to 4, and 60 to 120, and 120 to 240. Okay, so those would be the ratios respectively. Now, if we divide them out, they all equal to 0.5. And we can find this true for any ratio in any right triangle with a 30-degree angle. And we call this ratio of the side opposite of angle to the hypotenuse the sine of the angle. So what we're saying is sine of 30 degrees is equal to side opposite of 30-degree angle to hypotenuse. Hypotenuse. Okay, so that's the ratio. So any sine of a 30-degree angle is going to be the side opposite of the 30-degree angle, just that one, 2, over the hypotenuse. And it should always give you 0.5. So now let's look at cosine. Cosine is simply the sine adjacent next to the angle over. So cosine of 30 degrees is equal to side adjacent, I'm going to abbreviate, of a 30-degree angle over the hypotenuse. And I'm going to abbreviate hypotenuse. Okay, and that, if you divide it out, which would be 3.464 over 4, will give you approximately 0.87. For this one, it would be 103.92 over 120. This one will be 207.85 over 240. If you divide them all out, you'll get approximately 0.87 if we round. Okay, so now let's look at one more. So what do we want the ratio opposite of the angle next to the ratio of the side opposite the angle next to the side adjacent to the angle? So we would say side opposite of angle to side adjacent angle. This is called the tangent. So tangent of 30 degrees, so that would be 2 divided by 3.464, and if you use the calculator, you get approximately 0.58. And you can do it for all of them, and you should get the same thing. So that's all tangent is. Now, so there's not a definition or a theorem or postulate that we can prove this. We just have to learn these and memorize them. So if you look at your book, I'm not going to write these on the board, but if you look at your book, on lesson 43, page 191, you'll see down in the middle, it says, it gives you something to learn. So if you write these down in order, so if you write sine of A, cosine of A, and tangent of A, in that order, well, I know these are over the hypotenuse. Okay. This is opposite. This is adjacent. This is opposite over adjacent. And they use the little Oscar had, you can remember this little phrase, Oscar had a hold on Arthur. So O for opposite, H for hypotenuse, Oscar had a hold on Arthur. Oscar had a hold on Arthur. If you can remember to write these in order, sine, cosine, tangent, Oscar had a hold on Arthur, then you would know O stands for opposite, H for hypotenuse, A for adjacent, H for hypotenuse, O for opposite, A for Arthur, or for adjacent. This will help you to memorize which one goes in which order. And it's important that you learn this. Okay, so write this down in your notes somewhere, memorize it. Now, how do you use it on your calculator? Well, you use these little symbols that say sine, cosine, tangent on your calculator. Okay, so, for instance, if we want to find the sine of 39.2 degrees, okay, sine of that, you enter 39 point, first of all, your calculator must be on degrees. You do 39.2, and then you hit the sine button, and it'll give you 0.632029302. And we can just round to 2 decimal places, okay? If you wanted to find the cosine, you would again enter this and hit the button cosine. If you wanted to find the tangent, you'd type in the 39.2 and hit the tangent button. And that will give you what it is. Now, what if we wanted to do this for cosine of 57.2 degrees? Well, that's basically saying 4 times the cosine of 57.2 degrees. So you could do one of two things. You could enter your calculator 4 times, type in 57.2, and then hit the cosine button, and then the equal button. And you should get 2.166832841. Or you could start by typing in 57.2, then hitting the cosine button, then times the times button, 4, and then equal. And you should get the same thing. Okay? So we're going to round to 2 decimal places. Now let's look at the examples. It says find the sine of A and B, the cosine of B, and the tangent. So you round your answers to 2 decimal places. So the first one, oops, Oscar had a hold on Arthur. So Oscar had a hold on Arthur. Okay? So they want you to find the sine of A in the first triangle. I want you to find the sine of A in the first triangle. So, here we go. There's A, there's your right triangle, there's 7, there's 4, and 5.74. So sine is going to be opposite over hypotenuse. So what's my opposite of A? 4. My hypotenuse is 7. So you do 4 divided by 7 and you get 0.57. What's the cosine of B? That's the other triangle. So cosine is going to be the angle adjacent, and that triangle looks like this. This is B, angle B, 5, 7, and 8.6. So you want the cosine of B, so it'll be adjacent 7 over 8.6, which is 0.81. Okay? Now on the last one, they want you to do the tangent of C. So here is C, 6, 8, 10. So tangent is going to be opposite over adjacent. Opposite of C is 6. That's not adjacent, that's a hypotenuse. So this one's the adjacent. 8. 6 over 8 gives you 0.75 when you divide it out. Okay? Really simple, easy to do. You just got to memorize and know this is opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. Okay? So now we're going to do the inverses of these. So the inverse of a number is the angle whose sine is the number. So here's some examples. So the sine of 30 degrees is 0.50. So the inverse sine of 0.5 is 30 degrees. Okay, so the inverse sine of 0.5 is 30 degrees. So the cosine of 30 degrees is approximately 0.866. So the inverse cosine of 0.866 is 30 degrees. So how do we use a calculator? So let's look at example 43.2. It says find the angle whose sine, so the sine is 0.643. So you want to find the angle. And you want to find the angle whose cosine is 0.216. So what you're going to do is you're going to enter 0.643 in your calculator. You're either going to hit the inverse, or in some calculators it's the second to switch it over. And then you should see, if you hit inverse and then sine, and it will give you 40.0158, which is approximately 40 degrees. Now, my calculator, I have to hit the second degrees, and I have to hit sine with the -1, which indicates the inverse. Okay? Or your calculator might simply have the inverse button. So you would type in this, 0.216, hit the inverse button, and then cosine, and it will give you 77.5279, which is approximately 77.53 degrees angle. All right? And that is it.